Yes, that's right. This title is not clickbait. You can use this circuit with literally any LED, and you will not turn it into smoke. Let's get started. Alright, so for this project, we will need 3 components: an LED, a 10K ohm potentiometer, and a 5mm perf board. First things first, let's strip about 1/2 inch of wire off the positive side of the LED. Then bend one of the wires at a 90-degree angle and twist it so that it is easier to solder. Repeat this process for the other wire, and now you have nice little legs for your LED. Now solder the longer leg of the LED onto the wiper of the potentiometer and the shorter leg to the bottom pin of the potentiometer. Take your time here to make sure that everything is lined up properly, because if you mess this up, then your LED is going to be permanently damaged. So double check before you start soldering. We want the anode or negative side of the LED connected to the bottom of the potentiometer and the positive side of the LED connected to the wiper of the potentiometer. Once finished, it should look something like this. If you want to connect multiple LEDs in series, then you can do that. Just keep in mind that the voltage rating of each LED has to match, otherwise, one or both of them are gonna be destroyed. And always connect them in series, never in parallel. Once that is done, place the potentiometer on top of the perf board, center it, and then push down all 4 corners until the pins go through the holes of the perf board. Now take some jumper wires and connect VCC of the Arduino to the positive side of the potentiometer. Connect the ground side of the Arduino to the negative side of the potentiometer. Take your time here to make sure that you don't accidentally bridge any pins together. If you do, then your potentiometer might get damaged. After that, insert the potentiometer into the Arduino and select the pin that the potentiometer is connected to in the Arduino IDE. Now plug in your Arduino and open Serial Monitor so we can read the values from the potentiometer. As you can see, the value ranges from 0 to 1023. Now let's write a sketch that will control the brightness of the LED depending on the value from the potentiometer. Copy this code into your Arduino IDE, select the board and the COM port you are using, and hit Upload. Once the sketch is uploaded, open Serial Monitor so we can watch the values come through. Turn the potentiometer knob slowly, and you should see the value change from 0 to 1023. Now copy this code instead. Upload it to your Arduino and open Serial Monitor. Slowly rotate the potentiometer knob, and you should see the LED react accordingly. Now here comes the most important part. Do not rush this. Make sure that you understand what you are doing, otherwise you might destroy your LED. This is the voltage divider bias circuit. The way it works is that the voltage coming out of the 5-volt pin of the Arduino is divided between the potentiometer and the LED. When there is no load connected to the 5-volt pin of the Arduino, it outputs about 4.9 volts. We also know that the voltage drop across the LED is about 1.8 volts when it is running at full brightness. What that means is that if we subtract the 1.8 volts from the 4.9 volts, we get a maximum of 3.1 volts that we can drop across the potentiometer. We can also see that our potentiometer is a 10K ohm potentiometer, which is quite high. But the current flowing through the LED is very small, so this setup should work just fine. So far, so good. Now let's try out different resistor values to see how much current we can push through the LED without destroying it. Copy the following code into the Arduino IDE and upload it to the board. It is basically the same as before, only now we can see the current flowing through the LED. Open Serial Monitor and slowly turn the potentiometer knob. You should see the value increase, but keep in mind that if you turn the knob too quickly, then you might destroy the LED. Try to do it as slow as possible. And when you get to a value around 200 milliamps, you should see the LED start to flicker. At around 250 milliamps, the LED will probably turn completely off again. And if you continue to push more current through it, then the LED will die. This is the point where you have to be careful and stop immediately, because if you push too much current through the LED, then it will start to burn and you will not be able to use it anymore. Most LEDs can handle about 20 to 30 milliamps of current, and that is what this example circuit is designed for. Of course, if you buy a special high-power LED, then you can push more current through it. There are even LEDs designed to handle up to 1 amp of current. If you want to find out how much current your LED can handle, then you can simply measure it with this multimeter setting. Just put the multimeter in series with the LED and then turn on your power supply. Now, slowly increase the voltage until the LED starts to flicker. And once it does, decrease the voltage by about 50 millivolts, and that is the maximum you should use. I hope you got the idea behind this circuit. By changing the value of the potentiometer, we change the amount of current flowing through the LED, and thus its brightness. The beauty of this circuit is that you can use pretty much any LED you want. Even if it has a different voltage rating, you can still use it. For example, if you want to use a 12-volt LED, you can do that. You will only have to adjust the potentiometer value accordingly. Keep in mind that the higher the LED voltage rating, the higher the potentiometer value you will need. In this case, the voltage drop across the LED is 12 volts, and we want a maximum of 4.9 volts across the potentiometer. So by doing the math, we can figure out that we would need a potentiometer with a value of 22k ohm. But we could also use a 10k ohm potentiometer. In that case, we would only be able to get a voltage drop of about 24 volts across the LED. However, if you reduce the voltage of the power supply to 12 volts, then the problem is solved, and we can use our 10k ohm potentiometer. Another cool thing about this circuit is that we can also use it as a PWM signal generator. To do that, we have to change the output of the Arduino from analog to digital and use the built-in PWM function. Copy the following code into the Arduino IDE, upload it, and open Serial Monitor. Now when we rotate the potentiometer knob, we get a PWM signal out of the Arduino that controls the brightness of the LED. You can play around with the frequency and the duty cycle to see how it affects the LED. And lastly, if you want to use this circuit with a 3.3 volt Arduino, then you can do that too. Only now we cannot use the 5 volt pin of the Arduino because it is not regulated. Instead, we have to use the 3.3 volt pin. Keep in mind that if you use a 3.3 volt Arduino, then the voltage drop across the LED has to be lower than 2.4 volts. Otherwise, it will damage the Arduino. Also, if you want to use a 12 volt LED, then you have to lower the voltage of the power supply to 6 volts instead of 12 volts. You can also use a potentiometer with a higher resistance than 10k ohms. You can even go up to 50k ohms. Just keep in mind that you have to reduce the value of the resistor accordingly. Now you can use this circuit to drive any kind of LED you want, and you can also use it as a PWM signal generator. You can use it with a 5 volt or 3.3 volt Arduino, and you can even drive high power LEDs with it. All you have to do is follow the steps outlined in this video, and remember to keep the current low. If you have any questions, then leave them in the comments below. Thanks for watching, and see you next time.